there's kind of expect you to give some feedback, otherwise it's going to be a little bit boring. So, and the topics that I'm talking about, I'm not an expert in. So if anybody out there plays with these a little bit more than I do and realizes that, oh, he said something really stupid, let me know, because I want to learn from it, and I want you guys to learn from it too. So don't be afraid to call me out if I say anything, if I mislead anybody. So we're talking about the GPU. First off, how many gamers in the room? Okay, we've got a few. PC gamers. Okay, there's a few. Yeah. Can console gamers really be counted as gamers? It is, but can't quite do the stuff that we're going to talk about today on them. So first slide. Anybody know what the difference is between those two processors?
One had the arithmetic coprocessor, I think, and the other did not.
That's really, really close. So my answer was going to be marketing. Because
that's spot on.
Because they both have coprocessors. In the SX, it's disabled. So exact same chip, they just disabled it in the SX. And then in another bit of marketing genius, they sold motherboards with a coprocessor slot in it that you could buy a 487 chip in it, drop into that slot, and you get the coprocessor. Does anybody know what the difference was between the 487 and these chips? Just marketing. They were all the exact same chip. The 487 was the exact same chip as this. It was just repackaged as a math coprocessor. This was also the very first computer that I bought with my own money. And I stressed over this decision of, should I get the SX or should I save up for another few months and get the DX, because the DX had that coprocessor. It's kind of interesting. That's a little bit what we're talking about today. Talking about really specialized math processors.
Which one did you buy? You also got the DX.
No, I got the SX. I got the SX, and shortly after I got one of these for it. So this was 3DFX video card. They were one of the early consumer grade video cards. This was the version of the card that actually did 2D and 3D. So you actually had one card. Before this, you had generation of cards where you had your 2D card, and then right next to it you had your 3D card, and you had to mess with this little loopback cable and stuff. But this is the one I ended up going for. Now, today, we have something infinitely more powerful. I mean, it makes that last card look pokey by comparison. Your phone is more powerful than the last card, but this card right here is top of the line, current consumer grade GPU from NVIDIA. And one of the things that makes it really special for today is, in addition to the card, they have the CUDA programming library, which that's a CUDA, but it's not the programming library that we're talking about. We're talking about this one. So NVIDIA came out and they released a C programming library called CUDA that really taps into it, and it's beyond just gaming. So it really allows you to dig into the math capabilities of your processor. And the two technologies that we're going to talk about today heavily leverage that ability to get in there and really hit it hard. So we've talked about graphics cards. We're actually seeing right now a time when these cards are going beyond graphics cards. Bet you guys didn't know Microsoft makes its own cards. So this is Microsoft Project Brainwave. And they announced this at a conference called Hot Chips about 2 weeks ago. And this is a specialized silicon that they're working with Intel on developing for basically math functionality that they're using for AI. Based on what I can tell, they're not actually planning on releasing this to consumers. From what I can see, I could be wrong, but it looks like they're really designing it to use in their data centers to give them a competitive advantage in the AI marketplace. Microsoft's not the only one. Google is releasing a chip. They have the TPU, TensorFlow Processing Unit, real similar to this. Again, they're not really releasing it for consumer use. They're using it as a competitive advantage in their data centers. All right, so gotten a little bit of the hardware that we're looking at. So now we're ready to dive into the two topics. First topic is blockchain. And I'm going to start with a couple of easy questions. First off, what is money?
Something worth value.
Okay.
Medium of exchange.
Okay.
Gold.
Gold? Okay.
Simply you buy something.
Okay.
The fiat standard for exchange.
Okay. So the answer that I was going with, I think all of those are correct. Even gold can be used as money. Basically, it's nothing more than a collective agreement. Basically, a group of people saying this has value, and we're going to collectively agree that it has value and use it for all those purposes that were listed. If that agreement fails, the money fails, of course. So, given that, what gives our money its value? Belief a little bit. And I guess another way maybe to answer to oil. What backs the US dollar?
Nothing.
Nothing? Okay.
It's not backed by the gold standard
It's not backed by gold standard. Okay.
It's backed by the power of the sovereign government to tax.
Okay. That's a pretty good answer.
We have stuff that people want.
Okay.
We want our services and our goods. We need our tender.
Yeah.
So,
Yeah. Well, another answer in addition to those is debt backs our money. Holy cow, how does debt back our money? Well, when a bank loans money, they basically are they have a reserve of cash and they can lend so much money on top of that reserve. And when they create that loan, they're basically, poof, there's money. And so it's literally just a journal entry, they're creating money.
Because of interest.
Well, even beyond the interest, even before the interest comes into play, they're loaning that money into existence. That's why you see them talk about things like the Fed lowering the interest rate in order to increase money supply. So it's a pretty deep topic, but the fact that they can create money will come into play here in a little bit. So, what is blockchain? Does anybody know?
Block with a chain on it.
Okay,
A ledger of transactions.
that's a pretty good one. Which one?
Digital ledger.
Digital ledger? Yeah. Okay. Bitcoin. Yep. Lots of cryptocurrencies out there. I bet you since I started this talk, there's probably been 10 brand new cryptocurrencies started. And yeah.
in the last 5 minutes.
And out of those, probably 90% of them will amount to nothing, except make the founders a lot of money. So,
Ponzi coins? Crypto Ponzi?
yeah. Yeah. There's a lot, and it's interesting trying to pick them out. I will say, I should have said this at the beginning, I'm not a financial advisor, so don't take anything I say today and go and put your entire 401k into it. Any moves you make is on your own. Unless you do it and you get rich, then you owe me a fee. Okay? All right, so we're going to look at a demo of the technology that kind of drives blockchain. The demo that we're going to look at, it's a website tool. I didn't write it, so I just want to make that clear that I'm using somebody else's awesome work, but I think it's a really awesome tool for demonstrating some of the process that blockchain is. So, all right, so to start with, we have a hash. And as programmers, a lot of you probably are familiar with what a hash is. Take a chunk of data, you run a hash against it, and you'll get a thumbprint of that data that is unique to that particular data. So we can see down here I have a hash that starts with E3B. If I start typing something, every character that I change, that hash changes. So no matter what I type in here, I'm going to get a different hash value. So that's kind of the first step of building up this knowledge. Now, a block in blockchain is nothing but a batch of data with a hash that meets certain conditions and something called a nonce. Now, the condition that we're going to meet with our hash is it must start with 4 zeros. So we can see there's 4 zeros up there on the screen that this one starts with, so this is a valid hash. As soon as I start typing something in here, that hash changes. So it's not a valid hash. The way I get in there and I tweak that is I can change that nonce value and basically change that value, recompute the hash, and see if it starts with 4 zeros. And I can do that over and over and over again until I find a value that starts with 4 zeros. So I'm going to hit mine. And there, I hit it. I just mined my first coin. So obviously, if you're mining Bitcoin, the algorithms that they're using are a lot more complicated than that. But in this case, I mined my first coin. So just like the bank loaning out money, I just created money. So that's the block piece of it. The chain piece comes from it by adding in one more element into the mix. So you can see in that first window, we have our block, we have our nonce, we have our data, we have our hash, and then we have that little previous. Now, since this is the previous one, it has nothing in there, so it doesn't really matter. I'm going to ask you to pretend that the other ones don't exist on there, so pretend 2 and 3 don't exist. If I change this, it's going to break that block. It's no longer valid. So I have to mine. And then you'll notice, picked up hash, 4 zeros and a 2. And the next block also has that in its previous one. So that hash value is now pulled into that next block. And whatever data I put in here, again, is going to create a unique hash that I then have to mine against. So now I have 2 chains in my block. And I can continue to repeat this all the way through. Oh, that one was a little harder. All right. So we'll go with all right.
What is it doing with the previous?
So it's taking the previous. Well, I'll use this one. So it's taking the previous value, and it's the hash value from the chain before it, and it's incorporating it into the data that's hashing. So it's basically, you can think of it, it's concatenating the block number 2, the nonce 20989, the data JJJ previous, taking all of those elements and basically compressing them into one object and generating a hash against that.
And then the nonce for that.
Yep. And if any of those change, of course, the hash is going to change. So at this point, I've developed out a chain of items. If I change something in this one, that one plus everyone after it breaks because that previous value that's carried through, and it just collapses the chain from there. So this is kind of how, when they're talking about blockchain, this is kind of the core piece behind it that's doing a lot of the work. Now, there's a few other tabs on here that I'm not going to go over. You know, the distributed. I'm distributing on a single computer here, whereas out in the world you have millions of computers calculating these hashes and doing this work. But but the premise is largely the same. It's generating unique value and then generating a hash against it. And every time it generates that, matches that, it completes a transaction. We can have, in this demo, to make something that would be a little bit more in line with kind of what Bitcoin is, it could be John plus 100. And then I have to mine that. The next transaction, Jill minus 100. So you can kind of see how we can use that data packet to build a chain of information along there. So any questions about how that blockchain technology works?
Why do I care if you change number 2 if I'm on number 5,000?
Because once these are set, think of it like a bank ledger. So a bank ledger, if you kind of go the double entry accounting system, you shouldn't ever change a past value. You should modify it by entering a new value that adjusts it. So by doing it this way, you kind of set that initial value in stone. And once this is distributed across millions of machines, if anybody else changes that, it'll break. So it's a transaction. I gave you $100. That'll forever be there locked down. I can't come back and say, I didn't really give you $100 later on. So
do each of the machines out there that are doing this, do they all have all 5 of these at the same time? And to add on potentially?
Yeah, if you go out to any, and it varies a little bit from technology to technology, but like if you go to Ethereum, that's the one I dabbled with more, and you download their Ethereum wallet, it's going to take a little bit of time to start up because it's downloading this chain, and it's also computing. It's not actually computing the values; it's verifying the values. So it's checking to make sure that this hash really is the hash of this one, and this hash really is the hash of this one. Yes.
So going back to changing it, if it's early enough in the process,
Yep.
there's only 1,000 blocks, or 1,000 blocks. If I change block 1 and I have a computer powerful enough to recompute everything, is there anything stopping me from doing that?
No. When we get, and we don't talk about the distributed part of it, but when you do get into the distributed part, in order to basically take control of the network, you have to bring on 51% of the computing power. And 51% of the computing power would cost you more in US dollars than the entire market cap of blockchain, or of Bitcoin. So yeah, technically you could bring in that much horsepower and override it and rewrite history in that way, but it's going to cost you a lot to do it. And so, well, yeah.
So when you click on mine, I was looking for a hash that started with 4 zeros or whatever. What's actually going on there?
It's just, all that it's doing is we have this nonce value up here. It's starting at 0 and hashing that value out and seeing if the resulting hash starts with 4 zeros. Nope. Switching it to 2.
Oh, okay. So when you hit mine, it was
It's
cycling
just
through and finding
going
it.
through. Yep.
Okay, I thought the nonce was something you typed in. So it's
Nope.
I get it.
That's generated. So
So is it just appending that to your data?
yes.
Right,
Yeah.
Just doing a different.
Yep.
Sorry, that's question.
Oh, no.
Where's the data come from?
The data in the block here.
In reality, if I were mining,
Right.
where's the input come from?
It's going to depend on the actual cryptocurrency. But like if you're doing something like Bitcoin, let's say, that data is going to be transactions. So if you go to purchase something, and this is kind of a flaw that Bitcoin has at the moment, or not a flaw, a challenge that Bitcoin has at the moment, is you go to purchase something, give them your $100 or 100 Bitcoins, and that's going to get put on the network, and computers are going to start doing this math. They're going to kind of try and race to do this math to claim that Bitcoin. And so out there, amongst all these millions, they're going to start crunching numbers, and hopefully be the one to solve this problem for you so that they can earn a Bitcoin. And in exchange, once they do solve it, your transfer of money is forever locked into that ledger.
And they can go and trade their Bitcoin.
Yep.
At the same time.
Yep. And so the power went out because my Bitcoin machine, my Bitcoin mining machine just turned on, and it's
Is that what you were plugging in?
yes. Well, I can't afford the electricity myself. So, yes.
So are these kind of real-world examples where the exact hash of a previous block is used in computing the next one?
Yeah.
Isn't that there a problem of having data that's longer than the hash, computing a hash from data that's longer than the hash?
So no matter how much data you put in that hash, the hash will always come out to be the same length. There is, I think you're probably thinking about collisions. So if you can have, there is a chance of collision where you have this data and you have this data and they both have the same hash. Fortunately, that's exceedingly rare, and I don't think it's ever happened in any of the cryptocurrencies because they're using big enough hashing ones. But yeah, I can put in basically the entire works of Shakespeare in that, and it's going to hash out to be that exact same length. But if I change one character, I'm going to get a completely new hash.
SHA-1's only had one or two real-world collisions, and SHA-256 is
And-
far from it.
And this isn't, the hashing algorithm isn't the same one that a lot of them are using, but they're using a hashing algorithm.
But this is a good example of what it is and how it changes for each block in the chain.
Yeah.
And ultimately, my understanding is the cost of running a miner, you're not going to break even.
It depends.
It depends.
That's a tricky question.
Yeah.
It depends. Let me put it this way. There are people running mining operations where they probably spent multi-million dollars on the mining operations. And I don't know if they'd be spending that much if they weren't making some money.
They tend to make something over
Yes,
time.
yes. They may be gambling on this is a new coin with relatively low value, so I'm going to mine a bunch of it now, and then when it gets super valuable later on. Yeah. And I actually have, so kind of how I'm using this, and I'm going to switch back to the slide a little bit to kind of continue on with what you said there. Okay, so I do have a machine that right now, as we speak, is mining Bitcoin, or not mining Bitcoin, is mining Ethereum. These two technologies, especially the one that kind of drove me to have it doing mining, is I started playing with this machine learning, and needed a Linux machine with a GPU in it. I have a nice GPU in my Windows machine, but a lot of these libraries are more Linux friendly. So I was going out to cloud providers and paying basically $1 an hour to run my machine learning experiments on them. And so I sat down and I did the math one night and said that, gee whiz, for what I'm paying, if I built my own machine and ran machine learning experiments on it, and then when I wasn't using for that, set it to mining Ethereum or a cryptocurrency, I can probably recoup my investment in that hardware relatively quickly. I think based on the hardware that I got, I think my recoup window is about a year, depending on what the markets do. Right now I'm mining Ethereum. It changes a lot at the end of September, so that may tweak a little bit, but I can actually.
Why would it be seasonal?
Well, it's seasonal because electric rates are seasonal.
Okay.
So OPPD charges 10 cents per kilowatt, 10 cents per kilowatt hour in the summer and 9 cents in the winter.
And that somewhere gets mixed into the value of
Well, That's what it costs you to mine it. So there is I don't know if anybody has heard of a kilowatt device. You basically plug it into the wall and then you plug your computer into it and it'll tell you how much electricity yours is using. And so what I did is I basically,
Check them out at the library.
oh, yeah. They're really simple little devices. Plug it in there and you leave it and it'll tell you how much it consumed over a period of time. So I basically calculated out the GPU that I have doing the mining, about how much ether I get in a 24-hour period. Breaks down the average watts that the device uses. Break that up to daily kilowatt hours for the device, monthly kilowatt hours times your electricity costs, and it costs me about $11 if I'm running it for 18 hours a day, which is pretty common. I run it basically when I'm sleeping and when I'm at work. Yes.
So how much goes to AWS?
How much from OPPD? Oh, the sun, yes. That might factor into it, yeah. I mean, if you could set up your own solar array powerful enough to power your computer and then feed batteries to run it at night. I haven't tried. It is interesting, though. One of the more popular locations on the planet to mine Ethereum is Iceland, because consumer electric rates there are similar to what we are here, but they have very favorable rates if you're a large company and you can,
It's geothermal.
Yes. And so they kind of get cheaper electric rates, and so you see a lot of mining operations set up there.
The only thing to do in Iceland.
Yes, and it keeps them warm. But so you can see my monthly cost for running it 18 hours is $11.50 an hour, and I earn, based on Ether price of $303. Now I put the spreadsheet together probably about 3 weeks ago. So $303.
You're paying 11.5.
Yeah.
You're earning 40
Actually, that I believe, yes, yeah,
Ethereum's currently at 388.
yes. And so over the course of just 3 weeks, it's gone up to 3. So let's plug in 388 and see what I'm making right now. Making closer to $52 a month.
And your cost doesn't change.
And yeah, well, my costs will actually go down here. I can't quite remember when they go into winter rates, but I might actually have.
Yeah, but in general, they're not changing from week to week.
Yeah. So yeah, it's all these cryptocurrencies have kind of been on an upward trend. Again, don't take any financial investment advice from me, but I mean.
Are you going to then declare your machine as an expense and start doing on your taxes showing that you have the expenses? And
I am planning on, I have it logged, I actually purchased the machine out of my business account, and I'm planning on taking that to my accountant and saying, oh, you're going to hate me. How do you tax this Ethereum? And so, from my understanding, your earnings, you don't actually have to pay anything on it until you take it out and convert it to US dollar. Again, I'm not a tax professional, so don't take my word on that. Don't go and mine up $1 million and then get thrown in jail for tax fraud and blame it on me. So yeah. But yeah, at this rate now there is, with the mining, there is a change coming to Ethereum. What we looked at up on that last website demo was called proof of work, and it's what most blockchains use today. It's actually one of the most efficient uses of computing, inefficient uses of computing resources in the world, because darn near every computer in the world that's mining for Bitcoin or that cryptocurrency is going to be computing that same hash. And so it's really inefficient. To combat that, they have another option that some are switching to, called proof of stake. don't ask me to explain proof of stake because I don't totally understand it, other than you stake your pool of cryptocurrency that this is the right answer. So that's how it was kind of explained to me. I don't understand the details to it. It is going to impact this because Ethereum is moving to proof of stake at the end of September. So it will impact this mining operation here, but I can go to another cryptocurrency or whatever and start mining that too. So, and really for my tiny operation, the mining was just icing on the cake. It was really more so about saving the money on the machine learning costs.
So you said that you get back however much per day on average. How much did that fluctuate?
Well, it kind of based on that chart right there. It's kind of going to the biggest thing that's going to cause it to fluctuate is the price of Ethereum.
So you're like always getting 0.6 of an ether.
It's about
every day, regardless of what
yeah.
just based off the time you put in.
Yeah. If I were to go out there and start mining by myself, it would be, you can mine for months and months and months and never actually get a coin because you have to be the one to solve the problem in order to get it. So what's really common, especially with small individuals, is they'll join a mining pool. And mining pool is basically thousands and thousands of computers, probably millions of computers, all doing work and then splitting the profit from that work. So that causes it to be a little bit more leveled out and averaged. Otherwise, I could go for
You could go for years.
yes, yeah, you could. You may never get one, or you may get lucky and get two back to back and get, so. So if you look at, that is kind of a larger mining operation right there.
It's not your computer.
No. I believe that this one was from a company in Iceland. And at the kind of the peak, that the folks doing this are really math nerds. So they're in there taking the GPU and saying, okay, this GPU calculates this many million hashes per second, so it earns me this much. And they're looking at, okay, ATI came out with a new video card and it's really good at doing this, and it's not too expensive and whatnot. And when they find that perfect GPU, they buy it en masse. As a matter of fact, I read an article about a month ago that there was individuals, not companies, individuals renting jets, like big commercial transport jets, filled with GPUs because they couldn't buy the GPUs. They couldn't find them on the shelves in their country. So they were literally flying these GPUs. So if you are a gamer and you wonder why some of the video card prices haven't come down, it's because people are buying them up to run these farms. You can kind of see how they're set up down here. Motherboard down here, then they have a extension cable, so they don't actually have to have the cards plugged into the motherboard. And then they'll hang the motherboards up above, spread out so that they get more air because they're running pretty heavily 24/7.
Are GPUs the only thing that can be used for this?
There are other options, specialty miners. There's with Ethereum, where the price point is right now, it's mostly GPUs. Most of what I've been talking about here is NVIDIA GPUs, but right now, depending on who you ask, some of the ATI cards are the sweet spot for value versus results.
And you have one card.
I have one card.
Theoretically, if you had a closet full of Raspberry Pi 3s, which have a GPU on them,
Yeah.
is that a viable
No.
solution?
No. GPU, Raspberry Pi, yeah, it has a GPU, but its hash rate is going to be so low for the electricity that it consumes.
Okay.
It's gonna be negative gain. Yeah. So yeah, and that's one of the things that they do quite a bit of math on.
Like you can't even mine Bitcoin with GPUs. They have like specially made
Yeah.
chips that all
Yeah. The other thing is you also have to have a decent amount of memory because it's got to hold a lot of that history on there. So I think right now the lowest, I think you can, I could be wrong, but I think you can still mine Ethereum effectively on a 4 gigabyte card. But I think they're getting close to being pushed up to require more than 4 gigabytes. So, all right. So that's a lot about the hardware related to this. Yes.
So is it the whatever the technology is called behind SLI and Crossfire that makes GPUs the preferred better than like a cluster or just multi-core processors?
It's the fact that GPUs are really specialized math processors. That's what games largely rely on them for, is that they're really good at doing math. And it's that math that makes them really good at this type of operation.
Do they have like specific CPU instructions? Or?
They do. And they're, for like the NVIDIA cards, those instructions are exposed through that CUDA toolkit. And so yeah, really good at doing math. And special kinds of math too. So.
What factors determine the price of the Bitcoin and Ethereum and US dollars? And do they have like a stock market of their own for every one of them? So sometimes if you have, let's say, this much Bitcoin, you'll make so many dollars and vice versa for the Ethereum.
Yeah. The price of those cryptocurrencies, Bitcoin and Ethereum, is market driven. And so there are exchanges out there where you can go and you can spend your money on purchasing Ethereum or Bitcoin. And so it's largely those that market that's driving that price. And so.
And they're not tied to the US dollars. They're like gold. They're
Yeah.
own thing going on.
Yep. As a matter of fact, if you listen to some of the practical implementations of practical uses of these cryptocurrencies, they talk a lot about third world countries where they don't have banking infrastructure to begin with, that individuals who wouldn't have the opportunity to open up a banking account or a retirement account to put their money into can instead put it in this and in these cryptocurrencies, and that can hold the value for them. Again, I don't know how much that's really done outside of the States. I will say that as far as your main net cryptocurrencies, so your Ethereum and Bitcoin, probably the 3 things that are driving the price the most right now is speculators, people buying it today, hoping it goes up in the future. Miners, people setting up mining rigs and mining it. And unfortunately, but it's true, people using it in the black market and illegal goods and stuff like that. So there is legitimate uses out of there, but probably not enough to really drive its price yet.
You mentioned third world countries, and I understand that banking institutions are very fearful
Yeah.
of that because it would eliminate banks and move all transactions to handheld devices potentially
Yeah.
that they had, and so there would be a tremendous loss of market opportunity, various things. But,
Yeah.
for a country that doesn't have great infrastructure or other things, it has some viability.
Yeah, it's definitely an interesting aspect of it, and how it has the possibility of separating us from big banks, and so, or changing how those big banks do business. And so I think with any technology, the ones that are really watching it and ready to react will be in a great position to benefit from it. So.
What about the question of anonymity of Bitcoin, Ethereum?
Yes.
There is the possibility that it is not true.
It's not. As a matter of fact, I once had a conversation with an FBI agent, and she really quickly said that they love it when they bust somebody with Bitcoin because they can see a history of everything that they've ever bought.
That's how they
So,
one of the Silk Road
yeah,
follow-ons
yeah,
was the guy transferred Bitcoin to cash.
yeah. Because they have this ongoing ledger, once they identify one point in there, they have the entire history and they can kind of,
It can be anonymous if you run like a miner on the Tor network,
yeah,
and then you generate a wallet on the Tor network, and then you put it
Yep.
in that. But then
Yep.
once that transaction enters, like some sort of other way
Once-
to convert it to a currency, that's where you can.
yep. Or once you transfer it into your wallet or something like that. So yeah, there are ways that you can be totally anonymous, but it's anonymous in a way where they can see what purchases were made and what was done with that.
They can see the purchase and the transaction, they don't know
Yeah.
who it is. And
If
eventually,
you're,
it's
yes,
converted, they find out who it is, and then
Yeah.
if there is a reason for it, there's prosecution.
Yeah. So it's anonymous if you're extremely careful and know what you're doing. But yeah, as I've been playing around with it, I've kind of treated it like it's not anonymous. So
Are we just glossing over the part where you talked to the FBI agent?
they didn't have enough to hold me other than overnight. All right. All right. So Ethereum is a little bit different from Bitcoin, and it has this attribute to it called smart contracts. Now, I haven't done much with smart contracts, so I can't speak with a lot of intelligence on this subject, other than to say it's basically a way to write a program that will then run on the Ethereum network. And so, if you were to take a simple Hello World application that all it did was it logged Hello World, when you upload that to the network and it runs, it's going to log Hello World to every single computer out there mining Ethereum connected to the network. So this has some interesting some interesting possibilities for businesses to write distributed apps. Now, there's a lot of apps that run on mainnet. You also have the opportunity to fork and create your own. I think if I jump down to the bottom, Whopper Coin. So this is an article I just read this week. Whopper Coin was a story that I read of Burger King in Russia. They are trying out a customer loyalty program that is backed by a blockchain technology called Whopper Coin. And so you can go purchase your meals at Burger King. You'll get a Whopper Coin, and once you have so many Whopper Coins, you can trade it in for a free Whopper. Or, since it's just a digital currency, you can trade it to your friends, and they can collect it. And so I think loyalty programs is an interesting way. Everybody seems to have their own loyalty program. Wouldn't it be nice if there was just like the Omaha loyalty program coin, and you didn't have to worry about going to this store and finding that card and everything like that. Order fulfillment's an interesting one. Have you ever worked on a project where you had B2B aspects to it, and that other business that you were working with, they come back and they say, well, we didn't get that message. Your automated process sent something over to you, and they come back and say, well, we didn't get it, so we didn't fulfill that order. Well, with something like an Ethereum smart contract, if you have that order fulfillment set up on there, and they're all participating in that blockchain, it's literally a shared ledger of what's going on. So you have proof in that ledger that, yes, they did get that order. And so
you have proof that you sent it, and they tampered with the one on their end, and it shows that they didn't. So it's kind of you said and they said.
Well, if you're both participating on the same, so what it would be is, if we go back to, yes, if everybody is sharing the same chain, so what a common scenario would be is they probably wouldn't run it on the main network. They'd probably set up their own network, and they might have a contract of maybe each of these 5 companies is allowed to hook up 2 or 3 computers to the network and participate in this network. As long as they're all sharing that same chain, if anything changed in there, they'd know. Everybody would know. And so...
But you could always take out the last item in the chain.
Not once it's been confirmed.
Oh, I see what you're saying.
So as long as that last hash has been confirmed, and it takes enough time to generate the hash, that the next link in the chain is going to be in there before you can substitute.
So if there's a disagreement, is there some sort of intermediary that you go to that pulls and shows that these other 10 nodes on the network say this is the truth? Which side?
That gets a little bit into its distributed technologies that are built into it. But yes, there is a algorithm that's part of it, and so it will determine the truth. Kind of like if you had distributed SQL Server or something like that. It kind of knows how to work that.
So if they have a distributed run your program, what's stopping a virus or one across that network?
Interesting question. Nothing. I mean, I guess if you programmed it in a way, say interesting question, because there have been a couple of instances with Ethereum of people putting contracts out there and not, how do I say this? They're programmed in a language called Solidarity, which is a kind of a JavaScript-ish like language. And you can program it in a way that anybody can use that contract to take all of your money if you program it wrong. And that's happened a couple of times in Ethereum's history. The first one happened when it was really young, and somebody put a contract out there that allowed people to basically empty out the account. It was young enough at that time. The coin that Ethereum wasn't publicly traded yet. It didn't have a way to get your money out of it really. And so what they did is they forked the network at that point. And now if you look, there's actually 2 Ethereums out there. There's Ethereum and then there's Ethereum Classic. And that's because when they forked it, some folks said, nope, we don't want to participate in this fork. We want this Classic. We want it before the fork. And others, most everybody else participated in the ongoing one. And then there was another one just a few months back where some individuals lost $74 million, similar type of bug. And in that one, because it was traded in exchanges and stuff, the people that stole the money had plenty of time to get it out and transfer it over. So a fork really wouldn't have done them any good. It was just, sorry, you lost $74 million. So yeah,
Ethereum?
That was Ethereum. And it actually, as I was kind of watching that, I was kind of reading that, this could really damage Ethereum. And I transferred what little money I had out of Ethereum. Instead, the market reacted by going up. And I think the reason is because they stood by the contract. They said, this wasn't actually a flaw. It was somebody misusing it. And yeah, they lost their money, but we're going to stand by that this stuff was working correctly.
So the people that misused it did in fact have a loss.
Yes. Yeah. And I'm not sure if it was a group of people or an individual, but it was $74 million was the total.
So the misuse, so the person that lost money misused it? Or was
Yeah,
it-
they put a contract out that allowed other people to empty their money.
Okay.
So it'd be like if I took my wallet and just set it here and left it there and then came and got it tomorrow morning and all my cards are gone. Well, it's not your fault that I set it there. It's and so that's kind of how it was.
The system isn't flawed, the person just completely
Yeah.
examined.
What
Yeah.
was it that they did that makes it where they can do that? It seems like it would be a name and a number. Is it like they put a name and an asterisk?
It was. I'm not sure the exact details of it. I do know that Ethereum came back and they said, okay, this wasn't a flaw, but we are going to change the language around to make it harder to make this mistake. But I don't know the exact details of what the flaw was, or not what the flaw was, what the person did.
Forgot the weird clause.
Yeah.
How are these things managed? How is there like a central anyone making that decision?
Yeah, there is kind of to some degree.
The chains.
So with Ethereum, you know, they have this. Well, a better example is Bitcoin. So Bitcoin, about a month ago, they had kind of a little fork, and Bitcoin's at a point right now where a transaction takes a significant amount of time. So you buy something and it's like you have to stand there waiting for 15, 20 minutes for your Bitcoin to clear. A group of folks basically forked Bitcoin and created something called Bitcoin Cash in an effort to improve on that. And the community basically said, we're largely going to stick with the mainline Bitcoin. Now, Bitcoin Cash is still out there, and it's worth a couple $100. But yeah, so there is kind of a central authority. In that case, there was a group of people that forked it, but it was still up to the community to say which one they're going to give value to.
Is that the kind of thing where if the chain gets longer, they're going to have to do it again?
Well, that's part of the scaling strategy that a lot of the chains are or the currencies are talking about is moving over to this proof of stake, and so.
And they are going to. Bitcoin's already set to fork a second time, sometime in the next couple of months, to try and fix the problem again in a different way.
And so, and Ethereum has a scheduled fork, and it looks like, even though they're calling it a fork, it looks like it's going to, like most of the community is on board with it, and it's not going to end up being two. It's just going to be one going on. So you might be asking, what does this have to do with Microsoft? We're a .NET user group, we're a Microsoft user group. What does this have to do with Microsoft? Well, for starters, in Azure, they have Azure resource templates that you can use to spin up your own private Ethereum node relatively quickly. Might be wondering why I have a picture of Cocoa Puffs. It's because about a couple of months ago, Microsoft announced Cocoa Framework.
Wait a second, isn't that a violation? Somewhere in Cupertino.
So, Cocoa Framework is built upon, they're basically extending Ethereum, and they're really trying to make it suitable for use in business. So some of the things that they're really trying to add to it is scalability, confidentiality, so that you can, kind of like we talked about before, so that you can have more secure confidentiality, and consortium governance. And that kind of goes into play where you can specify on this chain or on this instance of it, each participant's only allowed to use X amount of computing resources, and they're only allowed to hook up this so that they can't overpower the network and basically hijack it for their own use. So it's really an effort from Microsoft to bring this into a more legitimate technology. They announced it a couple of months ago. They're releasing the first public preview of it sometime in the spring. So hopefully sometime next year I'll be back here talking specifically about the Cocoa framework.
So will Microsoft then actually be using its their processing power to actually be processing Ethereum and making money on their hardware and letting other run?
I don't think so. I think what they're really trying to do is they're trying to take the technology and package it up in a way that you can then implement your own on-premise, and so it won't be on the main Ethereum line. It might be a private network with you and 5 other companies that are working with you. So, okay. So, any more questions before we move off of blockchain?
Do you think the big banking institutions like Visa and MasterCard, they might use Ethereum or Bitcoin for their transactions?
They might. When you're talking about,
They already are. They're not using Bitcoin, but they have their own private blockchain network. So they did like the first transaction across the wire
yeah.
recently. But I think eventually like banking core systems and everything
I think you'll start to see it used, especially in like international transactions and stuff like that, where right now the rules is really kind of hairy if you're transferring banking amounts of money across international borders. Probably a ways off from individual, from individuals using it, largely because there's a lot of scalability issues. Like we said, it takes a Bitcoin transaction several minutes to complete, where your credit card, you swipe it and my phone's already buzzing saying a charge just went through. So.
But not everything has to be humongous lists in terms of the ledger size and things like that, right?
Sure.
I mean, this could potentially be used in real estate transactions, right? For ownership and such are used.
Yeah, I've actually heard a few theories on possibilities for using it for just that.
Okay.
Instead of having instead of you going to a titling company.
Records.
Yeah. You wouldn't go to a title company anymore. You just register it on the public blockchain. And so.
Do you see a big future as for developers to create, maintain, manage, add to, not for Bitcoin necessarily, but just for blockchain systems? Like it become its own language and everything? Could.
I'm really excited for this COCO framework to come out and see how businesses interact with that. There's a lot of B2B applications out there that they're just services talking to each other, and I could see a lot of those being replaced with a blockchain ledger. All right, so we're definitely going over on time tonight. That's good. All right, so I have 2 hours. All right, well.
This is where it's all going.
Yes. All right. So part 2, machine learning. Yes. So no, I don't think that we're in for a Terminator future with machine learning. I think it'll be a lot more subtle than that, but just as potentially, depending on how societies react to it, could be just as catastrophic. So why machine learning? First off, we're in the midst of a data explosion. This is from an IBM paper that they cited, and this was actually from a year ago. 90% of all data was created in the last 2 years. So think about how long we've had computers in our lives, and just how fast we're generating data, if that's how fast it's coming in. 80% of that data is unstructured. So that makes it harder for humans to consume it. That could be anything from pictures that we don't know what it is to just blobs of data. So one of the ways that machine learning is machine learning is one of the tools that's helping tame this data explosion. A good example, and I heard this on a podcast, and unfortunately I couldn't find the podcast to actually get back and reference it, but there is a telescope coming online, I think next year, and I think it was in Hawaii, that is expected to generate terabytes of data a day. Now, that's pictures, that's radio wave, that's basically the whole spectrum of stuff coming into this observatory. Terabytes of data a day. 1 day's worth of data would take an individual scientist, many lifetimes to review. So one of the things that they were talking about on this podcast is one of the techniques that they're planning on using is using machine learning tools to go through and scan that data so that the only thing that the scientists are looking at is the interesting stuff. So it's just bubbling up the stuff that's worth human eyes to look at and review. So that'd be a pretty cool job. You're only looking at the interesting stuff, none of the boring stuff. The computer's just getting rid of all of that for you. Yes. And I guarantee they're not getting rid of the data. That's even the boring stuff. They're storing it someplace. All right, so types of machine learning. And Last month, for those of you that were here, is Tom still here? Tom isn't. All right. No, other Tom. Last month, if you were here, Tom gave us an introduction on machine learning. And so I'm hoping to go maybe one step deeper and then actually give you an example of how Microsoft's doing it. So I wanted to start that off with a high-level review of types of machine learning. So first type you have is supervised learning. With supervised learning, you're going to have labeled data. So you're going to have a picture with a label. It's, here's a picture, it's a dog. Here's a table full of house prices. And so it's got some sort of label in it that you're already interested in. You can then break that supervised learning down into regression, predicting values. That'd be, an example would be with that table of houses. So that table of houses might have values such as the square foot of the house, the lat longe of the house, the color of the house, just anything that relate to a house. And then the label would be a price. And you can then use that data, you can train a model against that data to predict what a house price would be given those other features. So, and then classification is another category of supervised. That's the one that I'm sure you guys have had some exposure to, where you take an image and the computer can tell you what's in the image. I think Facebook does that automatically. If you post a picture up on Facebook, they right away tell you who's in there. And that's an example of a classification. They're basically taking that picture and saying it falls into this class. On top of that, there's unsupervised learning. That's when the data is not labeled. You just have a big old pool of data and you're needing to make sense out of it. So you'll leverage some of these techniques to go against that unstructured pool of data. And then the last one, this is probably the most interesting one. It's probably the one that's used least, but it's kind of the most interesting one. Reinforcement learning. So with reinforcement learning, you're basically setting up a loop that goes back into the system. So you'll have a reward at the end, reward value at the end, and it's going to loop back into the beginning of the system to change its behavior as it works its way through the system. A common example of this is teaching a computer to play a video game by playing the video game. And so, all right, so I have a quick demo of MNIST using Keras with CNTK. I'll go over that. So I have, when I'm running it here locally, I'm not hitting a GPU. I am running it in a Docker container, which I will be able to pull up here. And most of machine learning language work is done using either Python or R. I'll be using Python today. And I'll be using a tool called Jupyter Notebooks, and you can't see it up there.
Why Python or R?
I don't know exactly, other than the reason that I've heard is the thing that's driving these forward is a lot of academics, and those are languages that are much more popular in academic settings. So. But one of the tools that they have that's really common that a lot of data scientist individuals will use is a tool called Jupyter Notebooks. And it runs on a server, and then you can hit it via a browser. And so in the Docker container behind the scenes, I'm running this server with this Jupyter Notebook in here. And then you can type your Python in here and just execute it block by block. And it kind of, you also have markdown cells that you can enter values into. And so you can kind of keep your notes and keep this notebook with you and show a history of what you're doing. So I'm kind of going to walk through this. Up at the beginning, so this is Python code, but you all are familiar with importing a library. That's basically all that we're doing up there, is we're pulling in a couple of libraries from Keras. Keras is a high-level machine learning library. Underneath it, it can either use TensorFlow, which is by Google, or more recently it can use CNTK. CNTK stands for Cognitive Toolkit and is developed by Microsoft. So Microsoft is out there developing Python code, pushing it out into Python, into the world. So it's definitely a new Microsoft. So here, now, it's going to warn me a few things, and that's okay. I'm going to run it again just to make sure that the cache warmed up real quick. All right. So this next step, where it's doing that mnist.load data, mnist is a popular data set used by machine learning processes. What it is it's a collection of, I think, 70,000 28 pixel by 28 pixel handwritten numbers. And so they collected these, as I understand it, they collected these throughout high school in the Washington, D.C. area. And they're just numbers written on little tiny pieces of paper that they then scanned into the system and labeled so you know what those numbers are. So what we're going to do in this first step is we're going to go ahead and load that data in here. And we're going to split it into a training set and a testing set. One of the really common practices is you always save back a chunk of your data for testing. And that testing chunk, once you train it, you just need something to validate that your thing actually works against data other than what you tested it on. If you don't do that, you can get something that works really great against the data that you're testing it on, but fails to work against any other data. So what we have is we basically have a train X and a train Y, and X, I believe, is the actual feature and the picture of the number, and then the Y is going to be the label of what number it is. And we can see there's just an example of some of the data that's in there. You know, so we have something that's a, I don't know, is that a 5 or a 3, 0, 4, and a 1. And we're gonna, right now, it's in the data is in a grid, so kind of like you'd expect to see a picture. It's got an XY grid, and you can think of each pixel in there as just another address in there. We're gonna rearrange that to make it more familiar or more easy to work with. Basically what we're gonna do is instead of it being a square, we're going to lay all those out into one long, actually column. I did that as a row, but it's going to be one long column of numbers. So we're just going to take this row, stick it onto the bottom, this row, stick it onto the bottom, so that we have one long cell of numbers. And they have helper functions in there. So that reshape is basically saying, take these 60,000 records and turn it into one column of 784. Which I think if you do the math, 28 times 28 is 784. Any math whizzes? No? Okay. Good. So you'll never know if I'm lying about that.
That's why we use computers.
So you can see now I have a 60,000 in my training set and 10,000 held back for testing. Here's kind of the interesting part. Here's where I'm building up my neural network. Now, neural network is the thing that's going to do the actual work. I'm going to actually hit the next step so we can see the neural network that it's built. Dense layer, so you see two main types of layers in there. You see a dense layer and you see a dropout layer. Dense layer, this is what they call a fully connected neural network. So if we picture our picture, we're going to have a bunch of neurons, and actually several more than that, but each cell in this is going to be connected to a neuron. And each cell in our neural network is going to be scanning that an individual cell. And that's going to be mapped across the entire image. The dropout, so it's going to run through a dense network, and basically what each of these neurons in the network is, they're looking for one thing. They're just looking for one thing. What it is can depend on that individual neuron. Some of them will look for a high value, a pixel that's shaded in. Some of them will be looking for a low value, a pixel with nothing in it. But when they find that value, they're going to activate. They're going to turn on and they're going to send their message up to the next chain in there. And then the next chain is going to do a similar thing and a similar thing. In between those, there's going to be a dropout layer. And dropout layer is going to pick, in this case, 20% of the neurons and basically turn them off. We're not going to pay attention to you. So just a random 20%. And that's just to add a little bit of noise so that it doesn't get too good at solving exactly what we're throwing at it. Because otherwise it's going to learn, it's going to go down a path of just what you've trained it.
Does that 20% change for every test?
It's consistent for, I might get this wrong, but I do believe it's consistent for individual runs. There is seeding functions that you can use with these to say I want to seed it with this so that it is relatively consistent.
Can you explain why would you want to drop 20% of the data set?
It's just to add a little bit of noise. So if we could guarantee that every digit was written perfectly the same way, we wouldn't have to drop it. We could just say basically train it on this individual digit. But we don't want it to get it too good at reading one specific type, because otherwise it'll tend down a path where it's only reading that. So basically we're gonna train it to, this isn't quite how it is, but we all recognize that that's still a 7. Where if we didn't train it with that dropout, the machine would be confused because that's not a 7. So it's just to add a little bit of digital noise, random noise in there to confuse it, to keep it from getting too good at predicting its training set.
Like before you take an exam that's graded on a curve, it's like taking the smartest kid in class and whacking him over the head just to make sure everyone else.
It's kind of like doing that to 20% of the class. So, and now you know why I was talking to the FBI.
So is that like a fine-tuning thing to figure out what
Yes.
percentages are right?
Yeah. There is kind of, when you start reading it, I'm definitely not at this point, but when you start talking to people and reading blogs about people who do this, they do kind of develop a feel for it. And there are kind of some standard starting points. Like this particular one, we did 2 dropout layers, each with 20%. A lot of times you'll see the standard one is they say the first dropout layer do 20% and the second dropout layer do 50%. So yeah, it's a feel. So now we're going to compile the model, and that step was pretty quick. Basically, all it's doing is it's taking this neural network, and we built it up here. You can kind of almost think of it like almost like a factory function in .NET or something like that. We built out this factory to create it, and that next compile step says, go ahead and give me the actual neural network. So now, compile it, and now we're going to train it. So here what it's doing, and I have a little bit of time to talk because it does take a while because I am on a CPU. What it's doing is it is taking every one of those pictures and it's running it through this neural network multiple times. So I think this one goes through 20 times as an effort to train it. As part of its training, you'll normally see a curve kind of like this. Once you start training, it'll take off, at least on this particular data set. It'll take off and it'll get really smart, but then we let it train a little bit longer to just, takes a little bit of training to go up here, a lot of training to get all the way as smart as you want it, is what I'm trying to say.
Is that like a probability curve of accuracy?
Well, there is accuracy in here. So we can see the accuracy after the first epoch went up to 92%, and then it went up to 97%, 98%. So you can see that first jump was a huge jump in accuracy, and it's slowly getting a little bit better. 99%.
So your picture would represent that increase in probability that you
that you're, yeah. Now, this is also reporting its progress on that training set. It hasn't looked at the testing set yet. So we're going to run it, once it gets done training, we're going to run it against that testing set. Now, I can talk a little bit about GPU while this is going on. Here you can see each one is taking about 10 seconds to train. When I run this on a GPU, it takes less than a second. And so this entire, all 20 of these will complete in just a couple of seconds. And so that kind of shows you some of the power that the GPU can bring to this to really crunch through these numbers.
And you mentioned that this is Jupyter written, and you've got stuff written in Python. Does that interface with the CUDA library?
Yes. Kind of going through the stack, we have up at the top, we're talking to Keras is the high-level library that we're talking to. In this case, I've told it to use CNTK, Microsoft's Cognitive Toolkit. The way that I did that is this is in a Docker file, and I don't want to dig too much into Docker, but this is actually in a Docker Compose file. And here I'm just setting an environment variable called Keras backend equals CNTK. And Keras knows that it should look for this environment variable, and if it says CNTK, to use CNTK. Otherwise, it's going to use TensorFlow, and TensorFlow is Google's library. And so, I don't know, maybe some of you have heard about TensorFlow. It's a fairly popular library out there in this machine learning world. I will say that Microsoft's CNTK library is rapidly generating a lot of steam and excitement in the machine learning world. All right, so, okay, we're done training. Now I can report the results. And this is going against my test set. Now you notice my training set, we got all the way up to 99.52% accuracy. But then I throw my training set, or my testing set against it, and we drop down to 98.3% accuracy. That's pretty good, but the difference between there is kind of related to what they call overfitting. We've built a model that's really good at solving that training set of data. It's a little bit less good at solving other data. So overfitting, something you'll hear quite a bit talking about in machine learning. Just because you can build something that is so good at doing its job that it's really only good at what you trained it to do, not so good at what you really want it to do out in the real world. So now what we can do here is we reported back basically these next two blocks of code. This first block will grab a picture out of the testing set, and it'll print it up on the screen. So we're going to see a number on there. And then the second block of code is going to run that picture through our library and predict what the number is. So I need somebody to holler out a random number between 0 and 10,000. 42.
It's not random.
It's going to break, man.
42. All right, so now there's only a 98.3% chance that this is going to work. So there's a slight chance that this is going to come up wrong. So got a number 4. It predicts it to be a number 4.
I think it's a lie.
We didn't train it on letters. We only trained it on 0 through 9. Any other numbers? 5? See, I know 5 works because I tested that one. I tested 1, 2, 3, 4, and 5. 1. Yeah. Do you not agree?
We'll just
the number 5.
No, this is the
The
sorry.
index, I
Yes,
understand.
it's the index of the fifth element, and the index of the fifth element happens to be a number 1, and it comes back as a number 1. Which one?
7,018.
Like that. There's a number 5. All right, and it detects it as being a number 5. So. Nope. Nope, this isn't my test data. This is, it is a very, very popular test data set. There's, if you're looking for stuff to research on, there is just a ton of data that's out there pre-labeled for you. There's actually...
Does that happen to have come from NIST, National Institute of Science and
Yes.
Technology?
Yep, they were the one that coordinated it and labeled it.
They have time.
Yeah.
Do you have like some examples of real world business problems that they're using this to solve?
Sure. Has anybody heard of a small company that produces cars called Tesla? So I mean, they're using machine learning in order to train their cars. Now, I'm sure they're not relying 100% on machine learning. That they have some boundary conditions set up in their code that kick in certain cases. If you're doing like those Alexa devices, those Amazon Alexa or your Siri on your phone, or what's Cortanas, those are being trained with similar data. And kind of the interesting point about it is the more data that they get into them, the better they become.
Like those are
Big companies.
California.
Yes.
Is there more repercussions of tracking for like a company
It's still a growing market. It's still a field that I think is probably still dominated by the academic world. You are starting to see it come into business cases some. I think one way I tend to look at it is a lot of organizations have BI teams, and traditional BI teams are really good at looking at the past, taking data and seeing, plotting out a chart of where they've been, where a lot of this technology has the ability to give them some insight into where they're going. Basically fit a model based on their data that shows, here's where you could be with these changes.
IBM, with their big data initiative in Watson, they are offering this as a service
Yeah.
to companies big and small. A lot of it's in medicine and other places like that, but they're trying to make it like Microsoft is doing here. Dial up a neural net.
Yeah. Yep.
So,
Yeah.
and pretty successful with it.
Do you think of big services in the machine learning world?
Big services?
Yeah.
Like big?
Bing.
Oh, Bing services. Yes. Well, Microsoft has, so they have one of the things, and I think they're doing it through their Bing brand, is they have several prepackaged services so that you can upload an image to them and they'll tell you what it is. You can upload video to them and they'll break down the video for you. Things like that. I haven't played with theirs too much other than to know that they're out there, and looking at them, they package a lot of this up in a really easy to consume way so that you can pretty easily consume it with your .NET code and just making RESTful API calls across the wire. Another one that I also had to show you. Now, I didn't have an actual demo set up for this, so I'll just kind of talk about this one. In SQL Server 2017, well, let me step back. In, I think it was SQL Server 2016, Microsoft released support for the R programming language. In SQL Server 2017, Microsoft is going to release support for Python in SQL Server. So kind of like you can run .NET in your SQL Server instance, you can run Python and you can run R. And along with that, they've made a lot of library investments in order to make sure that the line between your SQL data and that Python code running in your SQL instance is kind of blurred and really efficient. I think this holds some really awesome potential for you write a model in Python, train it up, upload it to your SQL server as a stored proc that you can then consume from anything that can use SQL Server, including your .NET code. And as far as practical uses, I do tend to think that as this technology matures over the next decade or so, I could see it becoming as common in the solutions that we write as a SQL server is today. That it'll just be given that there's a machine learning component to your application at some level.
It would be nice if if I can create a machine learning software that does my tedious job like tests.
That does your what?
Tedious jobs like tests.
Yes.
So write all of my tests, and all I have to do is just focus on development.
Yes, it would be. There is, depending on who you, well, there was an article I read, I don't know, maybe it was 6 months ago, and it was a survey that went out to experts in the machine learning field, and basically it was a series of questions, and it was driving towards the point of when do you think machine learning technology and automation in general will be capable of replacing all human work. And the answer that they was getting was anywhere from the next 50 to 100 years. Now that's the technology being capable. There's still an adoption curve after that. But if you stop and think of what happens to mankind, I mean, at least here in the States, we identify ourselves by our job, by what we do for a living. And if computers are completely able to do that, it means some interesting questions coming up. And so
does that mean that the computer will then paint the Sistine Chapel on the ceiling of the computer room?
They're actually predicting that a machine learning generated novel will break the New York Times best-selling list in the next 5 years.
What?
That's an easy prediction.
Yeah. Now,
Here's the first novel ever written by a machine.
Yes.
You don't think people are going to go and buy it?
but it's
He just doesn't mind buying 2 million copies of their own.
yeah. Right now you have machines learning to play music based on listening to music. And that's kind of interesting because when you break it down, I had 3 years of piano, and as I remember it, math was a lot of what was in there. And so, I mean, really, music is a mathematical expression.
Never replace that human element.
Yeah, we'll see.
But the machine learning area will learn what humans like
Yeah.
and be able to
Yes.
be able to be creative along that line.
Yeah.
That's why painting the Sistine Chapel is not outside the bounds of possibility.
Yeah.
Because it will know that tone, that accent, that whatever it is, will be appealing to
To a human. Yeah. Yeah.
So,
And so yeah, I think there's some interesting developments that we're going to see. I mean, over the next.
I picture a community as you see in the movie WALL-E when everybody's on the ship.
Yeah.
Maybe.
But we are talking about artistic representation, but what about the other things that is more
Like what type of things?
inventions,
Yeah.
medicine?
Well, one of the areas that they do say will, even once this horizon hits that they do say will be in high demand is things that nursing staff. So, something that takes it wouldn't necessarily take a human, but there's going to be a human comfort level to it. But just at the opposite end of that spectrum is nursing will be in greater demand, but doctors won't be. Doctors will be replaced at some point. And so it'll be, here's your...
They're the technicians.
Yeah.
And not the caregivers.
Yeah.
Yeah, medical tool.
Yes. Yep.
I'm glad I'm married to one.
Well, I'm also partly suspecting that horizon of it really replacing all human work is probably past my lifetime. But you never know. I mean, if anything, being in the computer industry, I think things always happen faster than you expect them to. So.
Someone's still going to have to dust the CPU pool.
Yeah.
That's my future job. Now we move toward that, Star Trek utopia-ish.
Yeah.
Everyone has whatever they need, and
Yeah.
yeah.
It's yes.
Microsoft has any plans for promoting F# as a predominant language for machine learning as opposed to Python or R?
I don't know. I have seen that question been asked on different Microsoft machine learning boards and stuff. What about F#? Yeah, I don't know. Sorry. So here is a collection of resources for getting started. These are really only learning resources for the machine learning part of it. The blockchain, you're on your own.
I have one to add for
Okay.
apress.com.
Okay.
They're having their back to school sale. They have a book entitled Ethereum and Blockchains
Okay.
for $17.95. Find it on their website. And
I'll have to check that one out.
that's an additional thing among the other
Yeah.
ones. So.
Yeah, I've been. If you look at my library of Kindle books over the last 6 months, it's been sprinkled with blockchain and
Yeah,
machine learning
I think
books.
the depth of it is sort of modest.
Yeah.
But it's out there.
Still be good to get another perspective on it. So the top one, Fast AI, is an online course in machine learning. It's free. They have 2 courses out there. It's an excellent course. Unfortunately, I haven't worked all the way through it, but the parts that I have worked through it is just outstanding.
Can it solve itself?
Probably can. The book, so we didn't really talk about scikit-learn. That's another library similar to Keras. The thing that I really like about this book is it really breaks down the process, the data scientist process, how they would take a data set and walk that through the machine learning to extract the knowledge out of it. So it really gets inside that process that a lot of books kind of gloss over. A lot of books just talk about, here's how you build a neural network, where this takes you from exploring the data.
Clustering and all those things.
Yes, yep. So just for that alone, this book is up there. Math, I haven't got very deep into the math yet. How many had a linear algebra at any point during school? Oh, okay. It's more common than I thought. I never did. So this particular YouTube channel, it's called 3 Blue, 1 Brown. And it's he basically talks about math topics. I mentioned linear algebra because that is cornerstone to a lot of this technology. Now, the libraries hide that from you, but if you want to get further into it, you're going to eventually dig into that linear algebra. And I feel bad because like everybody raised their hand except for me. That's more than I did. That is more than I did. And then this last one, the machine learning YouTube channel, that is an individual, and I'm not even going to try and say his name. He's really energetic with his videos and how he's getting up there and talking about it. It's almost, I mean, just the energy he brings to it. He could be talking about anything and you'd be into it. but he's really talking a lot about machine learning technologies. So his channel's a really good one to work out. And I basically just grabbed the 4 that I think is the best. If you look at my bookmarked folder of machine learning technologies, it's got thousands of things in it that I'll need to write a machine learning algorithm to go through someday. And now, the final one. So this is kind of throwing something out to the group. I threw it out to Matt earlier today. There is a group out in California, and they're called Do-It-Yourself Robocars. Basically what they're doing is they're taking RC cars and putting Raspberry Pis on them, camera on them, and running machine learning algorithms on them to teach the cars how to drive. And then they'll get together every once in a while and they'll have a race around a predefined track and compete for time. And I was just kind of throwing it out to the group if individuals would be interested in basically setting up something like that here.
Are they using OpenCV?
There's 2 classes of them, or there's 2 kind of categories that they fall into. One is using computer vision, OpenCV. The other one is using straight up machine learning. And so they have a camera attached that's watching you as you drive. You'll drive it around the track a few dozen times, and it's actually learning from you driving it around the track. And so they have a website out there. They're going to make me open it in Twitter.
So it's just lines on the core.
Yeah, and it's learned. There's no human driving it right there.
But that's probably not follow the line technology, right?
Some of the OpenCVs are.
Okay.
See if I can find a better version of that.
First step is to be able to drive it. The first step is to stay in the lines.
Yeah. Well, and the cars that they're training are getting so that they're better than the humans. They're just based on what they're tweeting out. They're just now getting so that they're better than the humans training them. And so, but yeah, most of the time they don't run head-to-head like that. They just will take one car, run it for time, another car, run it for time. I think they took the 2 top cars or something like that and just ran them head-to-head to see what would happen. But if there's interest out there, building one of the cars, it's about $200 worth of materials. But that doesn't necessarily mean you have to buy one if there's other folks there that you can learn from and whatnot. So so it's a kind of another group that I'm kicking around with putting together. So if there's interest in it, I'll drive forward with that. So Matt's in.
Yep.
I knew Matt would be in before I even asked him.
Drone thing going, right?
Take it up a notch and have them be flying instead of cars.
Well, yeah. Yes. I've flown the quadcopters and I like my fingers, so I don't know if I'm quite ready to turn it over to just a machine.
Well, how's that work? Is it just is it actually tapped into the car itself, like some properties? You know what I mean?
So what they do when they train it, so the OpenCV is a different process, or the one that's using computer vision is a different process. The one that's using machine learning, basically what they do is they'll train it on the course beforehand. So they'll get there with a gamepad or a remote system, and it's sending the commands to the Raspberry Pi, and the Raspberry Pi in turn is driving the car. But what the Raspberry Pi is doing is it's streaming back to a laptop. Here's the picture of what I see. Here's the input that the human's giving me, and it's using that. here's what's out there, here's what the inputs are, to develop a process for what it should do in that same situation. And so you train it like that enough, it learns that, okay, when the road curves, I need to turn to the right. And it can kind of build up its process like that. Now, interesting, there was another individual who used another neural network to show what this neural network was doing and what it was seeing as important. It wasn't seeing the lines on the road as important. It was seeing the walls behind it as being important. So it was just picking that up as its frame of reference, not the lines on the ground. So.
Sort of like a teenage driver.
Yes. Yes.
Well, I mean, if it could like sense how much pressure is on each tire, on what type of turn, and that kind of thing, I mean, obviously it'd be way better than a human.
Yeah.
Because you could, instead of just guessing,
yeah,
it would actually know.
No. Yeah.
Optimize the path for time.
Yeah. Well, and the amount of effort that some of these people are putting out there, and you know, they're kind of tweeting about their progress, and they tend to keep their actual libraries secret until they've actually raced it, and then they'll release the libraries. But yeah, there's some of them that are, I mean, I came across one guy who was racing out here, and he was down to actually testing individual motors and getting the machine learning algorithm to understand what the response rates of the motors was and stuff like that. And so, yes?
When I was young, there was no machine learning, but there was something called artificial intelligence.
Yes.
So what are the similarities between the two things?
Well, okay, so first off, I'll answer it in a little bit different way. Machine learning has been around a lot more than people think. It's getting a lot of attention now because the computing power is catching up to what the math can do. There was instances of machine learning algorithms, computers learning to play like chess and checkers and stuff like that back in the 60s. So it's been around for quite a while. AI, I guess I would define it as AI is kind of a broader one. Machine learning can be underneath there. But then you can also have more rigid AI structures, where it just learns to do this one thing really well, but it doesn't have the ability to learn and adapt its behavior as time goes on.
They used to be called expert systems.
Yeah.
At one point in time.
Yep.
I remember doing some of that.
Yeah.
Using this for
Yep. So yeah, the machine learning has been around. Like I say, it's just now where the computing power is really caught up to it, and the GPU has really come into play.
What did you pay for your GPU? And when will it be paid for?
It's got so I purchased it about 3 months ago, I think. And if I look at how long it's going to take mining Bitcoin to pay for that rig, it's way too long. It's several years at just the mining Bitcoin. But if I factor in the money I'm saving by not running machine learning algorithms up in the cloud and by running it on premise, I'll pay for it in about a year. So, but do your own math. Do your own math. And so I barely trust my own math. I didn't take linear algebra, so. So, any other questions?